Um, what is X bar?
What does X bar mean?
No, no. Which number is X bar?
Which one came from a sample?
It's a 10.4, bro.
Okay. So, obviously on these, don't expect me to do this on the test, but I put in bold so it's a little easier to find. Right? So appreciate that way you can. And they're not always going to say less than 11 or less than whatever. They're going to say less than this other thing. Could be. So we develop a new drug. It's supposed to bring relief in less time than the old one. And what was the old one's time? 11.2. So our claim is that our new drug has an average relief time of less than 11.2, which makes sense. If you make a new drug that takes longer to work, good job, buddy. Right? So I know my claim here should be less than. I want it to act faster. So which one is that going to be? The high. It didn't have an equal sign in it at all. So it's definitely the high. And what's the ho going to be? So this is our claim. That's the last time until the last step that I worry at all about the claim. You with me? So the claim doesn't worry me at all until the end. Then I look back and say, oh, the high was my claim, and that's how I word things. Do we use Z or T scores?
T scores.
Oh, sorry, real quick. What, is it a 1 or a 2?
1 tail.
1 tail, and it's got to be down here. So I know that any score I find is going to have to be negative.
It's 1 tail because it's not, the ho is not equal to 3.
It's 1 tail because the high is less than. The high always sets up my rejection region. The ho is always cool with things being near the middle because it's going to have an equal sign in it. It's the high that tells me where I've got to go far enough away, which way to go.
If the high is not equal to, that's when we have these.
That's when you have 2 tails, because not equal would be, and actually in old books they used to say that, like this, with both of those symbols at once.
Yes.
And that people would get a little freaked out when we see 2 symbols in a row.
Actually, that would explain why we use 2 tails.
Exactly, it's a little more visible. So B, the key with this, and I've said this before, they're not going to say the sample standard deviation. They're not going to say S equals, not always anyway. Some of the problems do. Where did our standard deviation come from?
Sample.
The 45 students that they picked. So it is S. S is known. Sigma, not known. What else do we need to be able to use anything? It's got to be normal. It's normal because,
It's more than
yeah, N is 45,
more than 30.
greater than 30. Normal. But since I don't know the population standard, this is where people freak out. They always point and say, I know the standard deviation. It's right there. Which standard deviation do you know? That's the key. T-scores were invented to cover our ass when we don't know the real standard deviation, when we only know the approximation. So that's why I use a T-score. That's what they're made for. T. Okay? So now on the next step, I need to know what the hell to use before I can set up what far enough away is. I know that alpha is 1025. It's a 1-tail test. Here's where I would give you a little leeway. I didn't really necessarily do this on purpose, but N is 45, so what's the degrees of freedom?
44.
So technically you should use 40. If you used 45, I wouldn't take any points off, that's fine, it's close enough. But technically you should go down from there to be more conservative. So if you go to 40, what T-score do you find?
2.021.
Is it 2.021?
021.
And since it's down there, it's negative. Okay. So if, how can I say this? To use the symbol Z star or T star, I almost don't care. I almost want to make its own little stupid symbol up entirely. Because that's just a formula that I use to see how far away my sample is. This tells me how far away I've got to get. I want to use a formula now to figure out how far away my sample did get. Does it matter if I call it Z star or T star? No. But to be really super technical, if T star is less than this, then we can do what? Reject the ho. Support the high. Now some of you guys looked up the z-score by accident. The z-score you got was 196, right? Which one's an easier test to pass, if it was a z or a t? If it's 196, is that as far away as this says I have to be? So it's a little easier to pass that. It only makes sense. T-scores are supposed to make everything a little more conservative because we aren't as sure as we really should be. So actually my test gets a little harder. My sample has to be a little further away to cover for the fact that I don't know the real standard deviation. Yeah?
Can we write it as if T star is greater than or equal to 11.2, then we support the hull, reject the not?
Several things. 11.2 is not a t-score. It's a mean. It's a minutes.
Sorry, is greater than or equal to negative 2.021.
Okay. Second thing is you never support the null. You can never support the null. I can never take a sample and use a sample to say, yeah, it looks like the mean is 40. I can only use a sample because a sample is almost always going to not be the real thing. The whole point here is I can use a sample to get it so far away from what they think it is that it can't be that. I can say it ain't that. Then what is it? I don't know. I actually come out of this test not having a freaking clue what it really is. I can just say it ain't what you think it is.
So,
or I could fail to say that.
Could I say that if T star is greater than or equal to negative 2.021, then we fail to reject the null, or fail to support the
If you
null?
wanted to, sure. There's just more words that way, so I'd rather say. And this is more, this whole step is about setting up a rejection region. So I'd rather see that just reject. It should define the rejection region itself. Cool. That's here. Yeah.
We don't have a standard deviation. We do.
Rejection.
No, you don't. We don't change the standard deviation because the standard deviation came from the data population. You need to change it if your standard deviation.
That's what
So,
it feels like, because it's so
right.
open-ended, saying, okay, you can't reject it, so we have to do another formula.
I want you to realize statistics will almost always end up being open-ended. Because it's all about taking a sample. Can I ever use a sample to say anything really definitive about a population? Hell no. Right? I can never do that. Unless somebody said, I don't think anybody watches this show, and I say, well, he does. Well, then I can definitively say, somebody in the population watches the show. But that's not what we're really talking about here. I'm talking about claims like it's less than 11.2 minutes or something. I mean, if I take a sample, I can never say definitively that it is 10 minutes. But I can say that it's less than that. So there are, you could do, in chapter 9, we're going to look at 2 samples. And here we're just taking 1 sample. So what if I wanted to compare 2 samples? The steps are the same. Finding the rejection region the same. The formula gets a little bigger because I have to fit 2 samples worth of data into it. So the formula is actually big and people freak out about it. Well, it's the same stupid formula, really. We could do tests about standard deviations. The steps are kind of the same, right? So this format that we're setting up can be used for more advanced problems, but it's never going to kind of come to an actual, well, it is this. Never. All right. So step D is all about how far did we make it? What was X bar? And S was 234?
Yeah.
And N was 45. Now here's where people get a little freaked out. Always, when you have a test about a mean, what do you have to do first before you make a z-score? Change the standard deviation. When I do this, I'm not making a sample standard deviation. So people say it already is a sample standard deviation, Jeff. Why do I have to do this? No, this is a standard deviation that works for individuals. That's the key. It's a sample standard deviation, but it still is how far individuals are on average from the mean. I need the standard deviation that works for groups of 45. I have to do this step.
So it's got to be 2.3.
So when I do this, I'm not somehow making that into a sample standard deviation. No. That is a standard deviation of all samples possible to be taken from that, all the samples of that size. So I still have to do this. So S was 234, N was 45.
0.349.
0.349? And now I can make my, whatever you want to call it. We'll call it T star for now, since we're talking about T-scores. The formula is the same. It's still our score minus the mean, divided by the new standard deviation. It's just S instead of sigma, right? So it's not really different. Our score was 10.4. The mean, we're accepting it to be 11.2. And the new standard deviation was 0.349.
Negative 2.30.
Okay. At 229. 229?
Yeah. That's what I get to.
Right around there.
Stick up there, it's not.
Gotcha. 229, did it fall far enough away? Yes, cool. It's right there. It's definitely below negative 2021. So we can say right there, what can we say? Reject the host, support the highs. So the last thing here, and I want to speak to this real quick. These are perceived as really difficult because they're long. If you look at each step by itself is not difficult. But this is the same problem that every student has in every level of math. You step back and you look at the whole problem, you're like, holy shit, what the hell just happened? When really the people that do really well at math are able to look at each piece of it and say, that wasn't that bad, that wasn't that bad, that wasn't that bad. And I'm hoping they're not that evil. We know how to look up T-scores. We know what to check about whether to do Z or T. We hopefully know how to do this formula here. So which one of these is going to help me word the conclusion? The second one, because the claim was the high. Cool. So how does it start? Good. We have found sufficient evidence to support the claim. That what?
The new pain reliever drug relieves pain in less time than normal.
I like it. Works faster than the old one. Cool.
Can you do the P for the one before?
Oh yeah. Why could I not really do a p-value easily here? Because that's a t-chart. The t-chart is nowhere near detailed enough. Right? The z-chart's got a ton of areas. The t-chart, it depends on the degrees of freedom. There's nowhere near enough detail there. But the one before, real quick, remember the one before we got negative 181?
Yeah.
The p-value is just the area in the tail. Look up negative 181. In the z-chart, find the area in the tail. So if you look at negative 181, what do you get?
For the Z-score?
Yeah, that one, the first one was a z-score, remember?
Yeah.
0.0351.
Yep, 0.0351. P-value is 0.0351. And I think, let me make this point. The first one was a two-tail test, right?
Yes.
So what do you think you should do to this to make it fair?
1.8.
Double it. Because that's just one tail looking at it. You should double it to make it fair, because the whole problem is a two-tail test. Okay. Every time you think we're done, there's one more thing I know, but you just got to get in there and start doing this homework. Section 8.2 now, if you read through Section 8.2, they really explain each piece of it that we've done. And then 8.3, 8.4, 8.5 get into the actual problems.
Appreciate it.
Oh yeah.
I just have a question. The exam will be including 8, 9, 10, right? Chapter 8, 9, 10, correct?
The next exam? Yes. Yeah.
Because I'm almost done with chapter 8. I'm probably starting chapter 9. I'm doing the homework early. Just
Oh,
finish
cool.
everything.
Yeah. I like it.
Cool.
All right.